In industrial environments where explosive atmospheres are a risk, selecting the right pressure controls is crucial. These devices, such as pressure switches and differential pressure controls, must comply with ATEX and IECEx standards to ensure safety and reliability. When engineers are tasked with specifying instrumentation for these hazardous zones, they need to consider several key factors beyond just functional performance. First, let's talk about explosion protection concepts and certification. Devices used in these environments must feature appropriate ATEX marking under the Directive 2014/34/EU. This marking indicates the equipment protection level, or EPL, which tells us how robust the protection is against explosions. For instance, a pressure switch labeled 22GXD/IECEx GB is designed for use in Zone 1 gas environments, featuring a flame-proof enclosure that can contain any ignition that occurs inside. Some devices even carry dual markings for both gas and dust, enhancing their versatility. Next, we need to consider the selection of protection techniques. The most common method for pressure switches is the flame-proof enclosure, or XD. This technique ensures that if an ignition occurs, the flames are contained within the enclosure. Other methods like increased safety, XE, and intrinsic safety, XI, are less common in mechanical pressure switches, as they are typically used for low-power sensors. Now let's dive into key performance and mechanical parameters. The pressure range of the device is paramount. It must be suitable for the specific application and capable of handling overpressures. For example, PVL's Model 31 diaphragm switch has a range from 0.1 to 50 bars and can tolerate overpressures up to 300 bars. Choosing a device with an adequate safety margin, often 2 to 6 times the expected overpressure, is essential for longevity and reliability. Material compatibility is another critical factor. In harsh or corrosive environments, the wetted materials and seals must withstand the process media. PVL offers various options, including steel, brass, and stainless steel bodies, along with seals made from materials like Viton and Teflon. It's vital to ensure that the selected materials are compatible with the fluids they will encounter, especially in cases involving corrosive substances or particulates. Electrical contacts and ratings also play a significant role in the selection process. Most switches provide SPDT or SPST contacts, with options for normally open or normally closed configurations. The switching voltage can go up to 250 VAC, but it's crucial to consider the anticipated load and derating in hazardous locations. Additionally, the actuation hysteresis and repeatability are critical for maintaining stable control loops. Temperature considerations cannot be overlooked. The temperature classification of a device ensures that under the worst-case conditions, no surface exceeds the ignition temperature of the surrounding gases or dust. For example, some ATEX pressure switches can operate in ambient temperatures ranging from -10 to +75 degrees C. In extreme conditions, special designs may be necessary to maintain safety. Enclosure protection is equally important. ATEX-certified devices typically require at least IP66 ingress protection. Proper cable entry and gland selection are essential to maintain the integrity of the flameproof design. Mounting orientation can also impact performance, so it's important to follow manufacturer guidelines to avoid issues like condensation. When it comes to the PVL ATEX pressure portfolio, there are several standout options. The Model 31 diaphragm pressure switch is versatile, with a range of 0.1 to 50 bars and various body materials. The Model 48 piston pressure switch offers higher pressure capabilities, while the Orion MD differential pressure switch is ideal for low differential pressure applications. The Orion FC compound pressure switch is flame-proof and designed for high-pressure environments. Best practices in design, installation, and maintenance are crucial for ensuring long-term reliability. Choosing the right span and deadband helps avoid issues like drift or non-linearity. Mounting the switch close to the measurement point minimizes thermal lag, and proper electrical routing and earthing are vital for safety. Finally, maintaining documentation and traceability is essential. All certificates and calibration data should be kept up to date, and any modifications must preserve the device's certification. By following these guidelines and leveraging the certified devices from PVL, engineers can ensure safe and reliable pressure control in hazardous areas.